Welcome to the Strategy Room. Think of today's session not just as a math lesson, but as a masterclass in conducting an orchestra. Yes, you heard me right, an orchestra. I want you to start thinking of yourself as the symphony conductor of your Cambridge mathematics exams. Okay, let's dive into this explainer and unlock exactly what Cambridge examiners are looking for when evaluating functions in additional mathematics. Right off the bat, if you're taking syllabus 0606, 0580, or any of the advanced Cambridge variants, you already know that dealing with functions is a core part of the curriculum. But there is one specific type of question that continually trips up even the most prepared candidates, explaining in words why a given function does not have an inverse. Today, we're going to decode the examiner's playbook and give you the exact framework to orchestrate your arguments so perfectly that every single paragraph acts as an instrument in total harmony. Let's get to it.
Now, what's really interesting about this senior examiner insight is that this single type of question acts as a massive gatekeeper for top grades. It's not just about crunching numbers. It's about articulating mathematical reality. Let me introduce you to two types of students we see all the time. First, we have Alex. Alex overloads the paper with raw mathematics facts, writing down everything they know about parabolas, domains, and ranges, but provides absolutely zero analysis. It's a wall of noise. Then we have Sam. Sam rushes the question, completely misses the command word requirements, and just writes, "It's not one-to-one." Both of these students are throwing away easy marks, and their papers are covered in red ink. When a question asks you to explain why something is the way it is, the examiners are looking for a completely different skill set than just pure algebraic manipulation.
So, we have to ask ourselves, why do students find multi-stage analysis and method marks so incredibly hard to secure? We are going to answer this directly by looking at the exact methodology and the top pitfalls flagged in the principal examiner reports. The truth is, candidates like Alex and Sam lose marks not because their underlying math is entirely wrong, but because they failed to effectively communicate the required analytical depth. They miss the method marks because their process is hidden, rushed, or poorly articulated. We need to fix that right now.
Here is our roadmap for today's explainer. Section 1 is core principles. Section 2 is the procedural framework. Section 3 covers critical analysis, and Section 4 will reveal the top examiner warnings.
Section 1, Core Principles and Building That A-Star Foundation.
The assessment framework prioritizes this specific type of analytical depth. Examiners aren't looking for everything you know. Remember, Alex? They want to see how logically you can structure your reasoning. Academic benchmarks for explaining why a function lacks an inverse require you to prioritize precise definitions and causal relationships. You can't just write a paragraph hoping you hit the right keyword. You need a targeted, structured argument. To do this, top students use what we call the PEEL framework: point, evidence, explanation, and link. You make your mathematical point, provide the evidence from the specific function, explain how that evidence proves your point, and link it back to the core question. It's quality over quantity every single time.
Students who consistently score A-stars do so because they integrate these specific principles. Notice that third hallmark listed: leverage cross-topic connections. Principal examiner reports specifically highlight that candidates who reference cross-topic connections achieve significantly higher marks. This means linking your knowledge of quadratics, trigonometry, or calculus back to the fundamental definition of a one-to-one function. It proves a conceptual understanding that is fully transferable to unfamiliar contexts. Now, before we continue and reveal how to actually execute this, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. It literally makes the difference between struggling alone and having a master plan.
Section 2, the procedural framework and securing the method marks. The absolute brilliance of this standardized sequence is that it forces you to slow down and prove your process, which is exactly where method marks are awarded. Systematic processing follows these exact 5 steps. Let's think about how our student Sam could transform their rushed answer. First, you identify the key elements of the function. Maybe it's a quadratic with an unrestricted domain. Then you apply the relevant mathematical principles, like the horizontal line test or the definition of a one-to-one mapping. You execute the analysis with perfectly clear working, verify what you found, and present it clearly using that PEEL framework we talked about. If you skip step 3, you are throwing away method marks, plain and simple.
This is what we call command word decoding. When you look at a complex function, immediately run it through this 4-part cognitive filter before writing a single word of your final answer. Deconstruct what the command word explain is actually asking for. Extract the relevant data. What is the given domain? What is the range? Select your analytical framework, like peel, and finally, execute with clear, precise notation. This mental filter guarantees you are actually answering the specific question posed, rather than the question you merely wish they had asked.
The contrast between a messy, disorganized draft and a clean final copy brilliantly illustrates why presentation matters just as much as the math itself. Conventions are not optional. Examiners note that the presentation of information follows strict rules. You must use proper headings, correct mathematical terminology, and clear annotations. When students rewrite their answers live with this guidance, we literally see the red pen marks transform into green check marks. If you just write, "it fails," like Sam did, that isn't mathematical terminology. If you write, "the function is many to one within the specified domain, therefore an inverse does not exist," you have just secured your marks by using appropriate analytical formats. That is the true mathematics success blueprint.
Let's transition to Section 3, Critical Analysis and Evaluating Evidence Quality. But before we get into our interactive workshop, stop scrolling, subscribe to our YouTube channel Ace the Exams at @acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, welcome to the interactive workshop part of this explainer. This is where your data interpretation skills become absolutely critical. To write a perfect explanation of why an inverse doesn't exist, you have to extract information from texts and tables, interpret relationships, and actively note any limitations. Let's do a 60-second mental challenge. Imagine I just put a complex quadratic graph on the screen, a standard U-shaped parabola dipping below the x-axis with a domain of all real numbers. Scan that data. What is the inherent limitation? The limitation is the domain itself. Because it's entirely unrestricted, the curve goes down and back up. A horizontal line drawn through the y-axis will cut the graph twice. That is evaluating the evidence. Understanding how these limitations affect your final conclusion is the essence of critical mathematical analysis.
Think of your problem solving as a loop. Deconstruct, solve, and evaluate, ensuring every statement is fully justified. Now, let's do challenge number 2. Find the flaw. Listen to this sample paragraph. The function f of x equals x squared has no inverse because x squared is a curve, and curves don't have inverses. Did you catch the flaw? I'll give you a second. Exactly. The flaw is the lack of specific mathematical justification. Curves absolutely can have inverses if the domain is restricted. The examiner commentary here would be brutal. Now for our final challenge, speed writing. You have to deconstruct, solve, and evaluate. If you've stated a function has an inverse, but your working clearly shows a turning point within the given domain, your evaluation step should trigger an immediate correction before the examiner ever sees it. Make sure every single conclusion is rigorously justified.
Section 4. Top Examiner Warnings. We've talked extensively about what to do, but knowing what not to do is equally critical for your exam success.
There are exactly 3 major, recurring mistakes that sabotage otherwise excellent exam papers. These are the traps that examiners see year after year. To conquer these, you need the final, complete mathematics answering system. There are 3 rules that guarantee top marks. Rule 1, command word decoding. Rule 2, peel framework application. And Rule 3, a time management matrix, so you don't end up rushing like our friend Sam. By recognizing these today, you ensure you won't fall into them tomorrow.
Here are the specific warnings from the Principal Examiner reports. Warning 1, using the wrong approach for the specific context. Warning 2, forgetting to check format and presentation rules. But number 3 is the absolute biggest killer. Providing generic, memorized answers instead of applying the concept to the numbers sitting right in front of you. Reciting a textbook definition of a one-to-one function is completely useless if you don't connect it to the specific equation provided in the exam prompt.
Notice the stark difference between the classic trap on the left and the A-star approach on the right. The classic trap gets you minimal marks, while the A-star approach secures absolutely everything. Let's look at Sam's generic answer again. It doesn't have an inverse because it's not one-to-one. 0 marks for explanation. Now, a contextualized, scenario-linked answer using Peel reads like this. Because the quadratic function has a minimum turning point at x equals 2 and the given domain is all real numbers, the function is many to 1. This means an output of f of x equals a yields 2 distinct values of x. Therefore, no inverse function can exist. See the difference? We made a point, provided evidence from the equation, explained the many-to-one mapping, and linked it to the lack of an inverse. Context is literally everything.
If you take away just one thing from this explainer, let it be this ultimate rule for explaining mathematical concepts in words. Always link every single point to the given scenario. Treat it like a flashing red light in your mind. Whenever a question asks you to explain in words, your immediate reflex must be to look back at the specific data, the specific domain, and the specific equation, and weave them directly into your written response. Listen, students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but that only happens if they practice consistently with our weekly videos. So here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @ACExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @ACExams_IGCSE and click that bell. Don't let another exam pass you by.
It's time to put this into practice. How will you orchestrate your next explanation to ensure every single word earns a mark? Will you fall back on generic definitions like Alex and Sam, or will you use this procedural framework to systematically deconstruct, solve, and evaluate like a true symphony conductor? The difference between a B and an A star lies entirely in that exact articulation. Take this framework into your next study session and prove your math with absolute precision. And before you go, drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every single comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.